This is Mrs. Wainwright's math class, Chapter 1, Lesson 1.1d. Today we're going to learn multiplication patterns with base 10 numbers that are greater than 1. The learning target for today: by the end of the lesson you should confidently be able to say, I can multiply by powers of 10 by moving the decimal. And the first fact for today's lesson says, 1 times anything equals itself. This comes from the identity property of multiplication. 1 times anything equals itself. Or, conversely, the opposite is true as well. Anything times 1 equals itself. So let's see how this works. So my first example will be 1 times 5. 1 times anything equals itself. 1 times 5, 5 is anything, so that's going to equal the 5. Let's take a look at this in picture format. I start with 1, and I want that 1 5 times. 1 times 5, so I want 1 5 times. That's 1, 2, 3, 4, 5. How many squares do I have altogether? 1, 2, 3, 4, 5. So it makes sense that 1 times 5 equals 5. Or we could flip it around. Instead of saying 1 times anything equals itself, we can say anything times 1 equals itself. So let's try this one. Let's say 5, that's my anything, times 1. What will that equal? Well, anything times 1 equals itself. 5 is anything. So 5 times 1 equals 5. Let's check that out with pictures. I have 5, 2, 3, 4, 5 squares because I start with my 5. I'm going to multiply it by 1, so I have that 1 time. Oh, there it is. That's 1 time. I'm done. How many squares do I have altogether? 5. So we see that 1 times anything equals itself, and anything times 1 equals itself. The next fact we have for today's lesson is, when we multiply by a number greater than 1, the product, or the answer, will be greater than the number you started with. Let's take a look at an example for this problem. I'll take the number 5, that will be my starting number, and I'm going to multiply that times 10, and that will be my number that's greater than 1, because I think we can all agree 10 is greater than 1. So I'm starting with 5 and multiplying by a number greater than 1. So what does 10 times 5 equal? Well, we know that one. 10 times 5 equals 50. 50 is my product, which is my answer to the multiplication problem, and 50 is indeed greater than 1. And it's greater than the 5 that we started with. So, notice I started with 5, that's my starting number. I multiplied it by a number greater than 1, 10, and my answer was greater than the number I started with. It was greater than 5. Let's see what this looks like in picture format. My starting number is 5, so I'll start with 5 squares. I have 5 squares. I'm multiplying that by 10, so I'm going to have that 10 times. So I want to have 5 squares 10 times in all. Let's put another set of 5. That's my second set of 5. Keep going. My third set of 5. The fourth set of 5. The fifth set of 5. The sixth set of 5, the seventh set of 5, the eighth set of 5, the ninth set of 5, and one more set of 5, and the 10th set of 5. So I have 5 10 times. So let's go back and review those two facts. 1 times anything equals itself. And when we multiply by a number greater than 1, the product or answer will be greater than the number we started with. Let's put those two facts together to find a trick when multiplying by numbers like 10, 100, 1,000, 10,000. These are all numbers that are powers of 10. They have a 1 and zeros in them. Let's take a look. I have the problem 74 times 10. I see that 10 is one of those powers of 10. It has a 1 and zeros in it. So I know I'd be able to use this trick that I'm teaching you. So 10 is a 1 with zeros, and it is greater than 1. I think we can all agree 10 is greater or larger than 1. So my starting number was 74, and I'm multiplying it by a power of 10, a 1 with 0, and it's greater than 1. So the first thing we do is we take that starting number and we rewrite it on the side of the page. I have my 74, which is my starting number, and I wrote it there. For this trick, we will be moving the decimal in the number to find the answer. The only problem, when I look at that brown 74, I don't see a decimal. Does that mean it's not there? Of course not. I simply remove the invisibility cloak, and my decimal is at the end of my number. Look back on the left side at your pink 10. Remember, 10 is greater than 1, and greater has the letters R in it. What do those letters mean? The R means move my decimals to the right, which is this way. So when I'm multiplying by a power of 10 that's greater than 1, the way to make my answer greater is to move my decimal to the right. The R in greater is like the R in right, and that's how I remember my direction. So I want to move my decimal to the right. The first thing I'll do is cross it out because it's not going to be there anymore. And now when I get ready to move it to the right, uh-oh, there's no digit to move it around. What should I do? Well, anytime you want to move a decimal, if there isn't a digit to move it around, you can always add a place value 0. It's the only digit you can add is a place value 0. So I'm going to add my 0, and now I have a digit to move it around. And move it around one place. How did I know to move my decimal one place? Well, again, the R said to move it to the right, and if I look at my number that's greater than 1, my power of 10 number, it has 1 0 in it, and that 1 0 tells me that I need to move it one place to the right. So the number of zeros tell me how many places I move it to the right. So notice I have 740 decimal now. So what is my final answer? Let's rewrite it over here. 740. I can say my final answer is 740, just like that, or I can say 740 with a decimal. Either one is correct. My top number, the invisibility cloak, is on. My bottom 740, the decimal is showing and the invisibility cloak is off. Either one is a correct answer. Let's take a look at example number 1. 853 times 10. 853 is my starting number. I will rewrite that number. 10 is a power of 10, a 1 with zeros. And 10 is also greater than 1. Greater has R's in it. R's remind me that I have to move my decimal to the right. The question is, how many places do I move the decimal to the right? Well, let's look at that original number, which is the 10. How many zeros are in the number 10? That's right, there's 1 0 in the number 10. So I'm going to move it to the right one place. So I look at my 853 that I rewrote in red, and I see that there is no decimal. That's simple. Remove the invisibility cloak. There it is. I'll cross out my decimal since I have to move it. I know moving it one place to the right. Uh-oh, there's no digit to move it around. And when I move a decimal, I always have to move it around a digit. So I'll simply add a place value 0. Now I can move that decimal around the digit, and this will be my final answer. 8530. I notice that this number has more than 3 digits, so I do have to count back from right to left, starting with my ones place, and I have to count every 3 I put a comma. So 1, 2, 3, the comma will go between the 8 and the 5. So my final answer is 8,530. In this final answer, the invisibility cloak is on, so I do not see the decimal, but if I wanted to put it there, I could put it to the right of the 0. Please stop and complete your worksheet number 1. You can go back and look at this example as often as you like. Example number 2 is 32 times 100. Well, my starting number is 32. I'm multiplying it by a power of 10, a 1 with zeros. In this case, it's 100. Let's rewrite my starting number, 32. I don't see a decimal, so I'll remove my invisibility cloak to find my decimal. I know since I'm multiplying by a power of 10, a number that has a 1 and zeros, I'm going to be moving the decimal, so I'll X the decimal out and get it ready to move. The question now is, which direction do I move the decimal, and how many places do I move the decimal? So let's look at that power of 10 number, which is 100, and I know that 100 is greater than 1. Greater has R's, which means I'll be moving my decimal to the right. How many places? Well, let's count my zeros. 1, 2 zeros, so I'll be moving my decimal to the right 2 places. I'm ready to move my decimal in my red number, but I can't move it to the right because I have to move my decimal around digits and I don't have any digits. So what can I do to solve this? That's right, I can add in place value zeros. Now I can move my decimal 2 places, put it back in, and my final answer will be 3200. Again, in my final answer, I do see that there are more than 3 digits, so I'm going to count from right to left or count backward. Every 3 digits, I put a comma. 1, 2, 3. There's my comma. My final answer will be 3,200. I could have a decimal at the end if I'd like. I'm choosing not to. Please stop and complete worksheet number 2. Okay, let's take a look at example number 3. It's a little bit different. I have 734 and 6/10 times 1,000. Notice that my starting number, 734 and 6/10, already has a decimal in it. I will rewrite that starting number, 734.6. What am I multiplying it by? A power of 10, a 1 with zeros. This power of 10 number is 1,000, and I know that 1,000 is most certainly greater than 1. Greater has R's, which tells me I'll be moving my decimal to the right. How many places will I move it to the right? Go back and count your zeros. 1, 2, 3 zeros tells me that I'll be moving my decimal to the right 3 places. Okay, so go into my red number that I rewrote, 734 and 6/10, cross out my decimal. I'm going to move it 1 place. I'll have to add a place value 0 so I can move it 2 places. Add another place value 0 so I can move it 3 places. And now I can put my decimal in. 1, 2, 3 places. There's my decimal. My final answer is 734,600. 1, 2, 3, comma, 1, 2, 3. There isn't any other digits, and we don't start a number with a comma, so I have 734,600. Circle that as my final answer. Stop and complete worksheet problem number 3. Example number 4 is something else that you'll come across in some problems, so please make sure you're paying attention. 3,275 times 100. My starting number is 3,275, so I'll rewrite that. However, notice this, there is a comma in the number. When there's a comma in your starting number, ignore the comma and skip it, leave it out when you rewrite the number. So we're going to ignore the comma. I'm simply going to write 3,275. Now I'll look at my power of 10 number. It's a 1 with zeros. I notice that 100 is certainly greater than 1. And since greater has R's, I know I'll have to move my decimal to the right. How many places? 1, 2 zeros. So I'll be moving my decimal 2 places to the right. Oops. Okay, there's no decimal, so I'll simply remove the invisibility cloak. There it is. Let's cross out the decimal. I want to move it 2 places to the right, but I don't have any digits to move it around. Simple fix, add a place value 0. That's 1 place. Another place value 0. I've now moved it 2 places to the right. So my final answer would be 3, 2, 7, 5, 0, 0. That's more than 3 digits, so I'll have to count backwards to put my commas. 1, 2, 3, comma, 1, 2, 2, 3. There's nothing. Good. Circle my final answer, and it's 327,500. Remember, we never start a number with a comma, so you only put a comma if there was another digit in front of it. So it's 327, 500 with or without the decimal at the end. If your decimal is the last thing in the number and there are no digits after it, that end decimal is optional. Please stop the video and complete worksheet number 4 right now. So let's review today's lesson. We learned that 1 times anything equals itself. We also learned when we multiply by a number greater than 1, the product or answer will be greater than the number we started with. And finally, we learned if we multiply a number by a power of 10, that's a number with ones and zeros, we can simply find our starting number, rewrite it, deleting any commas, look at our power of 10 number and decide if it's greater or less than 1. 1,000 is our power of 10 number. That certainly is greater than 1. Greater has R's. Means my decimal is going to move to the right. I have 3 zeros, so it's going to move to the right 3 places. So I cross out my decimal. I move it to the right 1. Add a place value 0. 2. Add a place value 0. I've moved it to the right 3 places. I rewrite my answer. 3, 9, 2, 4, 5, 0, 0. I can put the decimal in if I like, and if it's more than 3 digits on the whole number side, I have to put my commas. So I'll count back 1, 2, 3, comma, 1, 2, 3, comma, and my answer is 3,924,500. Or I can write it without the comma, 3,924,500. And either one would be a correct final answer.